Hello, everyone. So, did you notice anything? Did you notice anything? I'm finally on a streaming software, so I have much more tools. You can see I have, let me remove that for now, then I will show you. So I'm on StreamYard, so that's why you have, where is that? You have this. I haven't bought it yet. I wanna try it and see if we can have more fun with this. So I'm supposed to be able to share the screen. I can highlight the comments. I can draw. We can do some giveaways. I can share like different screen. I can have some guests. So I think we can have a lot of fun. So I want to make sure, like, am I live? Okay, like, is it the song okay? The video is okay? Because I tried yesterday and there is quite a delay between the chat on YouTube and then when it comes to here, like 10 seconds. So I just want to make sure that I am live. You're live and good. 3D Medic Things. Thank you very much. So we have, okay, great. And we have, oh, Chris Prillo is also here. Wait, this is not Twitch, but it seems that with StreamYard you can broadcast on different platforms at the same time. So I see that a lot of people are trying to grow the 3D printing community on Twitch. So maybe I can try to help by having this stream also on Twitch, so we have more 3D printing content. But very nice. So I mean, I love this tool. I mean, it took me like 15 minutes to set up everything. I have now, where is that? I have a small Polymaker now here, and then I can highlight comments. So when we are going to start answering all the different questions, I can highlight them. Especially this one, for example, that's a lot of beautiful filaments. Exactly, we have all our silk series here. There's one missing, which is the chrome, which is a new one, and then we have two new that are coming. One that is an idea from Loyal, and then we have another one that is specifically developed from our R&D team. A great idea of another silk filament. But yeah, so like I said, you saw at the beginning, I can have like a small intro video. I have a banner, and I have this. Right, so you can enter "I'm awesome" in the chat, and then at the end of the live stream, I will be able to draw a winner, and there is a nice video and stuff to draw a winner. So overall, I think that's gonna improve a little bit the experience of our weekly stream. But definitely looking forward to use more this tool. And then I have I was thinking about some ideas. For example, now I can share the screen with my video on the side. Then I was thinking we could go from, like in the Reddit. I noticed there's a lot of questions about 3D printing in the Reddit. So I was thinking, as a community, our small group of 10, 20 people, we just go through all of these Reddit, and then we just help everyone. Because there's a lot of questions. I mean, we can help them very easily. So we just go through, we help them, and then some of the question might be a little bit more challenging, and then we just brainstorm together, and then we leave answers to everyone. So that's some of the ideas. So we have Maker Meteorite that joined as well. What's your favorite color? And I need to get used to this, so I will highlight first. What's your favorite color and that you got next to you? My favorite one is the purple. Is that one? That's my favorite one. That's one of the latest we released. Oh, by the way, I can also change the camera if I remember well. Let me check. I think I need to do that. And then I switch to, yeah, this one. So that's the webcam from, so it's a very nice silk purple. And then I go back to this camera. Yeah, so easy. I'm going to set up multiple cameras, so I will have a printer also on the side. So we are, like I told you last time, we are going to move to a new office. So I will improve a little bit the setup so that we can analyze 3D printing a little bit more. What was the last thing you 3D printed? It's not here. It's a small animal. So I designed on Blender. I designed a collection of animals, and I'm working on my series of sea animals. And then I designed a whale, and I tested it whether it was printable or not. So that was the. I'm going to release it as my new collection for the kids. I'm trying to design a digital collection of animals, and then the kids can select which animal they want, and then they just print them, and then they just play with it. Santiago, I'm awesome. Yeah, I know you are awesome, Santiago. Brian Farmer, I'm awesome. You guys are all awesome. So make me right. I just finished a prototype of my robot head in your magenta pink. Yeah, I think I saw the tweet, and I think you're going to present that robot in 2 weeks or something like this, right? And I asked you whether you could send me the link and the time so that I can put it on my schedule. I have a lot of different Twitch stream, YouTube stream. I'm trying to check around all the different the different 3D printing content, the different person that are spreading 3D printing, and I make a schedule. It's hard to keep up with like attending all the stream, but I'm trying to join them and see how I can support them with maybe with some filament or with maybe some knowledge sharing in order to grow more and more that 3D printing community. Jay, I'm awesome. I know you are. Kong the Bomb, any chance? Oh, I forgot to always share that that comment. Any chance of getting bigger spools of Polymax? So we have the 750 gram and we have 3 kg. So do you know about that 3 kg? If yes, that means you want a bigger one. And yes, we will come with a 5 kg spool. If no, then check out our website. We also have Polymax PLA. So I guess you're talking about Polymax PLA, right? Because we also have Polymax PETG and Polymax PC, but they all come in 3 kg, except PETG, but will soon come in 3 kg. So yeah, if you know about the 3 kg, the 5 kg is coming soon. If you don't know, then you can check the 3 kg spool. One Raz, I'm awesome. I know you are. I retyped because the first one did wrong. Yeah, so let me check if it's working well. Yeah, so we have 7 entries so far. So I mean, your odds are very, very high on our stream to get your Polymaker spool, and it's the spool of your choice. So you can choose any product from our portfolio, and then I will send it to you. The last winner was Abdullah, which I think was here. I think I saw. Yeah, that was Abdullah. And then we ship it to him. I think he is from Mauritius, or how you pronounce that? Yeah, Mauritius, and I think in East Africa, like island East Africa, if my geography is correct. Abdullah, correct me if I'm wrong. And we just ship it to him. He chose his spool, and then we just ship it to him. Polymaker, don't stress, much love. You owe me nothing, brother. Yeah, but I want to get to that stream. I want to see you're posting a lot of very interesting content. So I wanna be able to participate in your community as well. Chris Prillo, I'm the Polyterra Army Red. Oh, really? Did you receive the spools already, or you're still waiting for it? Okay, great. So do we have the regular one? Non-fan is here. Great. Abdullah is here. Santiago, of course. Is Josiah here as well? No, Josiah, no. Jay is here. Great. A lot of people. So today, the first part. So usually the stream will start with like 15-20 minutes of a specific topic, and then I'm going through all the questions and answer them regarding 3D printing. So today on the first part, we are going to talk about printing speed. And well, I just realized that my team just prepared all our different materials that we can break. We literally have everything. ASA, ABS, PC, Polymax PC, PC ABS, PC PPT, PS6GF, PS6CF, PS12CF, Polymax PTG, Polysmooth, Polylight PTG, Polylight PLA Pro, Polyterra PLA, Polylight PLA, Polyterra PLA Plus, Polymax PLA, and Polywood. I think we have pretty much all of them. 1, 2, 3, 4, 5, 6, 7, 8, 9, 10, 11, 12, 13, 14, 15, 16, 17, 18. Oh, a little bit some missing. But we have pretty much all of them. So if you guys want to break some stuff, I think I have enough to break. So yeah, we are going to talk about printing speed. So printing speed, what do you guys do if you want to increase the printing speed? So let's say this guy, okay, I know there's a lot of people printing articulated prints or print in one, or I saw a lot of print like this. So if you have this print and let's say it's taking, I don't know, let's say it's taking 12 hours to print this one, and you want to decrease the printing time, what are your first thoughts? What do you do to improve the to decrease the printing time? Let me know in the comment all your different ways of decreasing that printing time. I know Loyal is printing those big helmets, Star Wars helmet, Stormtrooper or any other helmet, and he also did a lot of work in order to bring that down to I think less than 48 hours. I think he brought that down to 40 hours if I remember well. So there's a lot of tips and tricks in order to do that. So I want to take like 10-15 minutes to discuss a little bit all our tricks to decrease printing time. Yes, I'm printing a Darth Vader with it right now. Oh, really? Okay, that's awesome. So you receive the spool, you put it on the printer straight away. That's awesome. And then we have increase the heat and speed. Okay, that's interesting. So indeed, let's talk about this. If you want to increase, so maybe the first thing that comes in mind when you want to decrease the printing time is to increase the printing speed, right? So how do you do to increase the printing speed? The problem with increasing the printing speed is you are going to require more pressure in the nozzle in order to extrude your filament. So you have two ways. You have two ways to increase the printing speed. Either you just force the extruder to create more pressure in your nozzle. So you literally just enter 100 millimeter per second in your slicer, and then your printer is going to just push more filament as the nozzle goes, more filament, more millimeter per second. Now, what problem that could create? It could create that your stepper motor is not powerful enough to handle that pressure. So you can think about it by having the filament in the nozzle that cannot heat up enough in order to lower its viscosity in order to be extruded. So the good point, what who was that? What Maker Millwright said was he increased also the temperature, and that's very important because the viscosity of the material needs to be the same when you increase the temperature so that you don't have under extrusion issue. So if you end up increasing your printing speed, then remember to accordingly increase the printing temperature. I'll give you an example. I printed a big vase on a Mass Portal Delta printer, and I printed it at 300 millimeter per second on the slicer, and I think in reality it was around 180 or 190 because of the acceleration. So it was just going in vase mode like this. The problem is at 210, the PLA couldn't extrude because it didn't have time to heat up. So I printed this vase at 280 degrees. So just to give you an idea of how crazy the temperature can go if you really print fast. I'm not talking about putting a high number in your slicer, because most of the time if you print a Benchy, and you can do the experiment, you go to the slicer, you put a Benchy, you slice it at 60 millimeter per second, you slice it at 150 millimeter per second, and you slice it at 300 millimeter per second. You are going to realize that between 60 millimeter per second and 150 millimeter per second, you will have a small decrease in printing time. But from 150 to 300, you will have almost exactly the same printing time, even though you double the printing speed. Why? Because the nozzle will never have time to reach that high speed. It will accelerate until reaching your maximum speed. But the Benchy is so small that it will just barely have time to accelerate, and it will already need to decelerate before arriving to the next corner. So that's why I was printing in vase mode. So that's the first thing. So that's a good point from Maker Millwright. The first thing, increase your printing speed, but make sure that at the same time you accordingly increase your printing temperature. That's why I like to talk about extrusion speed and extrusion temperature. If you have all the same, I give you one theory. If you have all the same setting, and then you have a certain extrusion speed, which is, let's say, 200, and then you keep the same printing temperature, and the layer height was 0.1, then your extrusion temperature is 200, and then you increase your layer height to 0.3, and you leave the temperature as it is, then you are going to realize that the extrusion temperature will be lower, even though the printing temperature is the same. Why is that? Because you increase your layer height from 0.1 to 0.3. It means there is much more material that needs to be extruded in the same amount of time, which means you have increased the extrusion speed. You have increased the flow of material that go through the nozzle. So that means just by increasing your layer height, you may already have some under extrusion issue, even though you're printing at the same temperature. So anytime you increase the extrusion speed, you increase the flow of material in the nozzle, then you have to look at the temperature. So if you increase the printing speed, if you increase your layer height, if you increase your extrusion width, if you increase your extrusion multiplier, whatever you increase, make sure that you understand that this is highly related to the flow of the material. So you will have to control the viscosity of the material as well. So you may have to increase the temperature. Sometimes it could be only 5 degrees more, and that already compensate. Sometimes, like my example of printing PLA crazy fast, I need to almost 150% of the regular temperature just to being able to print with the same consistency. So that was point one, just simply increasing printing speed. We do have Santiago. I go to sleep when I want to decrease printing time. That's awesome. You know, that remind me. You know, I don't eat in the evening. I do some fasting, and how I deal with that is I go to sleep the earliest possible so that I can get breakfast faster. So that's why I love, because that remind me this. The next one we have from 3D Medic Vince, increasing layer height to 0.3. Okay, so that's the second one. So we have increasing printing speed. The second one is increase your layer height, and that's for me one of the best way to deal with printing. That's one of the 3 ways. I have 3 favorite ways of decreasing the printing time, and layer height is one of them. Why? Because you can think about 3D printing is a layer-based technology, right? So each layer will take a certain amount of time. So let's say you're just printing a simple model, right? Let's say, do I have this one, like a simple model, and then you will almost have the same time per layer, right? I mean, the time is decreasing as you go up because the layer time will decrease here because you have less to print. But let's say you have a cylinder like this, then the printing time is the time that it takes to print a layer multiplied by the number of layers, right? So if we keep that simple definition, if you increase your layer height from 0.1 to 0.2, you theoretically divide the printing time by 2 already. You get what I mean? So like on one side, you will take twice the time to print one layer, 0.1 plus 0.1. On the other side, you will only print 0.2. So going from 0.2 to 0.3 will also have a decrease of 150%, right? Or 50%, depending on how you take it. So that's why I think for me, the layer height is the one that will affect the most your printing time. So indeed, I think 3D Medic Vince, I think that's one of the best suggestion if someone is looking to decrease printing time. Now there is a trick. If let's say a lot of people exactly this, you see, I have a high layer height. Oh wait, let me take advantage of my new setup. There you go. So you can see that towards the top, you can see the layers more than towards the bottom, right? Not the best print, but you get what I mean, right? So the issue here is, I hope I have some hotkeys that I can just. So the issue is that you are going to have, the steps between layers. If the slope is very high or low, depending where you take, then you are going to see the step of these layers more if you have a high layer height. There is one trick: is there is a lot of slicer that can use vario layer height, or how do you call it already? It's like a variable layer height. So when you have a very vertical wall, it's going to use a very high layer height, and when you are going to have this rounded shape or like the very high slope, then it's going to use a finer layer height. So then you can take advantage of, you don't need to compromise between a high layer height, a lower printing time, but a coarser result, or a fine result, but a longer printing time. You can have both with that new feature. So I think that's pretty much it for layer height. Do we have any other suggestion on decreasing printing time? I usually, so from Kongda Bomb, I usually adjust the layer height. So instead of 0.2, do 0.24, 0.26. I try not to go 0.3. Yeah, exactly. You know, when you're doing your slice, you will try to go as high as you can. You know, sometimes going too high will not have very good results. But if you can get like 0.21 or 0.22, that's a huge gain in terms of printing time. 0.3 for a 0.4 nozzle might be a little bit overkill for the 3D printer, though still possible. But you have to manage well the other settings. Nice choice. I did that. So we have Make a Mirror. I did that robot head in 16 hours with one nozzle and 450 grams with 0.32 layer height. Great. 16 hours. That's pretty good. I don't remember the scale, but I see on the picture that was a pretty big piece on the 3D printer. Jay saying Loyal brought it down to 38 hours. Yeah, that big helmet in 38 hours. That's already pretty good. Is there any other tips you guys are thinking about if you have to decrease printing time? I find no matter what, the first 3 layers don't need to be relatively slow. Okay. What do we have? One Raz, is there a chart to help with print speed and temperature setting? Unfortunately, not. We don't have. How to do that? You know, to do that, we would need either to test, you know, but the problem is all the different hot end, all the different extruder. We would have to test on every single printer, and each test would need, depending on the printing speed, what temperature, and then we would need to find a way to, we would need to find a tool that could tell us the viscosity of the material. So there is one tool that I love, and I wish 3D printer has this. I will tell you one of my secrets in my mind to make 3D printing much better, or at least from my opinion. I always wanted 3D printers to have a pressure sensor in the nozzle. What does that mean? It means that the printer will always know when the pressure that is in the nozzle. So you can do, I mean, there is some printer company that did that already, but only in their lab. So basically, you have your nozzle here, right? You have your nozzle, and then you have the let's say the hot end here, and there is a gap in between, and then there is a gauge that go in between, right? Well, not the best thing, but and then when the filament push on the nozzle, then it will create pressure, right, between the hot end and the nozzle. So it will push on it, and then this gauge will be able to record the pressure. So that means if you are printing at a low temperature, then it will require more pressure for the filament to extrude, right? So then it will require more force. If you're printing with a high temperature, then the viscosity of the material will be lower. So it means it will require less pressure to extrude. So now you have an exact index or measurement that shows you how healthy is the print. Theoretically, you need the pressure to be exactly the same for one layer. When you retract, the pressure needs to go down to 0. And when you re-extrude, it needs to go back to exactly the same pressure. So now you have an exact measurement of how good is your print or how good is your printer. You can just analyze the pressure. What do you guys think about this idea? I mean, there is much more in that topic that maybe we don't have time to cover today, but I would really love that printer can know the pressure, because think about that. If you have an under extrusion issue, what is most likely happening? Well, sometimes it's the extruder that becomes weak or something like this. So the pressure maybe, no, actually it also, yeah, it's good for everything. If you under extrude, it means maybe it's pushing too much in the nozzle, but nothing come out. So the pressure increase. And if the 3D printer knows that, then he knows that there's something going on. I mean, the pressure is all over the place. And if it's clicking, then there's some pressure, and then release pressure, then pressure, release pressure. Clicking is, when the stepper motor is skipping some step. And I mean, with the pressure, you can know everything. Let's say the pressure start to increase slowly, and the 3D printer knows that. Then he will automatically increase the temperature. Then it will lower the viscosity of the material so that the pressure decrease again. So you can control the last stream we were talking about smart printer, right? So that could be a smart printer. He has access to all the settings, and then he just needs to make sure that pressure is the same. I mean, there is a lot more that goes into that, but to simplify, the pressure needs to stay the same, and then he just play on all the things. If the pressure goes up, then increase the temperature. If it goes down, too much stringing up, he decrease the temperature, and then he just keep that pressure in the same. Maybe I get a little bit when I talk about this kind of thing, you guys need to stop me, otherwise we will never finish that stream. Next one. Okay, so sorry, let's get back to it. We were talking about how to decrease printing time. So we have increased printing speed, increase the layer height, and then we talked about for each of them, because it's always a compromise between quality and printing speed, and for each suggestion of decreasing your printing speed, we talked about how to not compromise on the quality. Abdullah, okay, answering to One Rice. I also use Prusa Slicer variable infill. Okay, so that's another one. Let me put it in the screen. So we have 3D Medic Deans that talked about variable infill, and that's another very good point, is the Infield density. So think about it. You have what? 90% of your print in terms of volume, not the volume of the material, but the volume of the model, that is infill. So obviously, oh, is that opening? Does that open? Oh, cool. Look at this model. Just open there. So you have 90% of your print that is infill. So definitely your infill a setting will be very important, whether it's infill printing speed, whether it's infill extrusion width, whether it's the infield density or infill pattern. So variable infill. So variable infill. What's the purpose on infill? Let's think about this first, because the best solution is remove infill. If infill is a problem for printing speed, then just remove it. But before removing it, we have to understand what's the purpose. Well, I think there's two main purposes for the infill. Purpose number one, mechanical property. So it will give, it will make your part more solid. It will give some properties. It will make it more durable. It will make it stronger. It will have maybe more impact resistance with this infill. Second reason why you would need infill is top layers. Because if you're printing, let's say you're printing this type, right? And there is no infill inside the head, then all of this at the top, you would need, it would be from the inside, it would be an overhang, right? But as there is infill, then it supports that face, right? So so first, mechanical properties. Second is the supporting your top layers. I don't know if you guys have other ideas, but that's my two ideas at the moment. So how can we get rid of the infill without affecting these two? Mechanical properties. I have seen a lot of white papers that were analyzing the effect of infill density, infill patterns. Well, not a lot of white paper. There's only one that come to my mind, but two actually. Yeah, I think there's two. I have read at least two tests that was saying that the shell, the number of shell that your print has will have more impact than the density. So let's say you're printing at 20% infill or 50% infill, the difference, like the increase in mechanical properties you are going to have thanks to this 30% additional infill would be less than if you go from 2 shell, like 2 perimeters, to 4 perimeters. Does that make sense? Like perimeters is the number of shell that your print has, like the outline. Why all the slicer has different name? You have outlines. I think it's like the simplified 3D is the number of shells. Cura is the number of outlines, and then you have inner outlines or outer outlines, or then you have what? You have perimeters. I think it's Prusa or Ideomaker is called perimeters. But yeah, they're all referred to the same thing. I wish there is some kind of standard way of describing infill, perimeters, or brim, number of brim, layer height, this kind of thing. Well, at least they all call layer height. I hope it will stay like this. Yeah, I lost myself again. So infill density, yeah. So for mechanical properties, you can almost get rid of the infill and just have a lot of shell. Now you have to make sure that you do increase your printing time by removing the infill and adding the shell. Theoretically, the shell, depending on the model, should be faster to print than even a 10% infill, depending on the infill pattern. You also have, depending on the infill pattern, you have triangle, rectilinear, honeycomb, and some of them are faster than other. And I think on Cura, you even have an infill pattern that says the fastest one. So that's an infill pattern. I think is the triangle one or close to the triangle. That will be the fastest way of printing. So that would be more on how not to compromise on the mechanical properties. How about the top layer, which is the second reason why we have infill? Well, I think that's exactly what 3D Medic Vince said. In order to compromise, in order to not compromise on the top layer, then you just start with a very, very low infill percentage. And then you just grow that infill to an infill percentage that would be dense enough to support your top layer. Let's say you're printing a big cube, right? Then you just start with I don't know, 2% infill, then 5%, then 10%, and 20% should be enough to cover, to bridge the top layer on top of that 20% infill. If it's PLA, you can go down to 10% and add a little bit more top layers, and that should also do it. So that saves all the printing time inside that cube. If you think about the helmet from Loyo, I don't know what infill he's using, but looking at the print, it seems that you wouldn't need infill, at least on the side, right? And he does not require high mechanical property, right? So maybe 3 or 4 shells, maybe no infill, and maybe just some infill at the top, or maybe somewhere with the top layers with some details. And I mean, most likely he already did that, but just to give an example. So infield density, great. You can start with manufacturer suggested spec, tweak, turning on, connect infill. Any other ideas on how to decrease printing time? Abdullah also used variable layer height. UAV Hero, I just joined my faster printing. Let me put that on the screen. Welcome to the stream. I just joined. My faster printer setting on my Ender 3 is 0.28 layer height with a few walls. If I don't need a strong print, yeah. So that's using the second tips. That's pretty good. Again, increasing printing speed. We talked about it. Increasing layer height and infield density. And then a few walls. The walls won't take that much, but if you already remove the infill, then yes, the next step would be to remove more and more walls. I mean, that's why vase mode is the fastest, right? No infill and only one shell. Then it's pretty fast. Okay, so we have Santiago that is talking about turning off fill gap between walls. Yes. I thought that was turned off by default, but I guess depending on the slicer. So you will have, for example, if you're printing, well, depending on what Santiago means, but there is two things. If you're printing a triangle, then you will have the first shell that will go one way, and then the second will go this way. But at the tip of the triangle, you will have a small gap. So there is a feature where the slicer will come and fill that gap. There is another one is for thin wall. If you are printing, let's say your extrusion width is 0.4, but your wall, your model, like let's say you're printing this upright, and then the thickness of that spline is 1 millimeter. Then if your extrusion width is 0.4, then you will go 0.4 one way, 0.4 the other way. So in total 0.8. So you will have, there is a setting that will go back and it will extrude this 0.2 left in between. So if you remove that, then you can also save some time. So you have to go through your setting and see what the G code is doing, or what the slicer is asking your printer to do. Santiago, Prusa XL does that of measuring pressure, I think. Oh, really? Is that true? Let me record that. The Prusa XL. So that's pretty interesting. XL. I will check that. If they do, then I will definitely get one here. I think we can study 3D printing very, very well and more accurately if we have a printer that is able to output that measurement. Or we need to build one. Like if there's one of you that like making stuff, if you can make that for a printer, and then we just do some tests together. We actually have a machine that do that. Maybe I should present this to you. We have a small machine, but I will check. I will check with our R&D if it's something that can be presented. So it's called our extruding machine. Okay, so Any other ideas? Try to eliminate movement without printing. So we have an idea from NonFam. Try to eliminate movement without printing. Travel between layer using grid or triangle infill to lower infill printing time. Try to eliminate movement without printing. Travel between layers. Between layer using grid or triangle infill. So what you're saying is, what you say between layer, so you mean so there is a starting point and there is an end point for each layer. So what you're saying is using the infill algorithm to make sure that the end point of the layer will be the same as the starting point of the next layer, so that you don't have to move, right? So I don't know if there is a specific one for that, but yes, indeed, if you print one layer and then you finish, and then your end point is the same as your starting point, then you will only need to go up and then start the other layer, right? So I'm not sure if it what you meant, but yes, that would save time. And in other words, yes, you do need. So I will record. Avoid nozzle movement without printing, without extruding. So no unnecessary nozzle travel. So you can have this by, for example, there is a combing mode. The combing mode that is always trying to avoid, which is theoretically helping with artifacts on the print. Like I told you already, I really don't like combing mode. I don't think it's working at all. I think it has to be combined with a very, very good flow management system in order to be useful. But if you have combing with a bad flow management system, then combing for me is very useless. It actually makes the print worse than what it should be without combing. So I would highly recommend to remove all of this unnecessary movement that would avoid the part. There is specific case where combing is very useful, but not in the way that I think it was intended when it was created. UAV Hero in Cura, let me put that on the screen. In Cura, with model needing support, I use 3 branch support, 1 wall thick, 0 support infill, with 100% roof of support to unnecessary support where it's important. Yes. So that's one. You remember I told you there is 3 main parts that I do when I want to decrease printing time. And one of you mentioned the first one, which was the layer height. And this is the second one, which is support. You have to make sure you have to use, let me record that. You have to use the least support possible. Support is completely useless in terms of your final print. However, it's the only way that you could print specific parts. Like if you are printing my flexible snake, then there is no way I could print the head without support, right? So theoretically, this, you see, the support will come from here all the way up to the head, right? So you will have to lose all of this. But there is some other way which Loyal is using for his helmet. You just start the support from the side, of the print, like from the neck, and then from the neck you go in diagonal. And then you just use, we can print overhang up to 45, 50, maybe 55. You can even have a very bad overhang. I mean, it's support. It doesn't really matter. Then you have very bad overhang here, and then you build your support on top. So now you only have this gap that needs support. That saves a lot. Like UAV Hero is saying, you can also use tree support, which means if you have to support a big area here, instead of printing the whole support from bottom up, you just print a small trunk, and then it will just branch out, and then you have a very flat, nice support, and then you print your bottom layer on top of it. So definitely a smart support management is very important for to decrease your printing time. So I will record support management. So we have 5 now: increase printing speed, increase layer height, infield density, not using unnecessary nozzle travel, and support management. So I think we still have at least one that I'm thinking about, but please tell me some other ways that you decrease the printing time. We have just got finished. Let's print something. Oh, Builders Mark just joined us. Just finished with work. Let's print something. Let's go. What are you going to print? What color are you going to print? What material are you going to print? What setting are you going to use? So 3D Medic Beans 0.8 nozzle will do the same thickness of 2 walls with 0.4 nozzle, but in one pass. Yes, that's another great point. Bigger nozzle, faster printing. So of course there will be some downside of using bigger nozzle, but if you think about it, 0.8 or even a 0.6, you in one pass, how you call that? Yeah, one pass. In one pass, you are going to, like for the 0.8, you are going to do the job of 2 pass for a 0.4. So definitely you're gaining a lot of time. And if you tweak your setting properly, you will be able to find a way to not have to not see that you are using a 0.8 nozzle by using a small layer height. So you can use 0.8 with 0.25 layer height. The problem with 0.8 is the XY details. So, well, also, yeah, XY details, yes. So it means it will, let's say you have a wall, and then you have, let's say you're trying to print something on the wall. So it will do some small movement so that when you finish the wall, then you have a writing. Then basically the 0.8 will kind of smooth out all the detail because it's so big that big nozzle will print. And then if you have a very sharp angle, then that big nozzle is going to round up everything. So that's the downside. So if you don't need that, then definitely bigger nozzle will decrease your printing time by a lot. So what else do we have? Jack Lee's Aquarium. Is there any coupon code available for Polymaker filament, please? We do have one that is called Polymaker. Let me put that in the chat. Polymaker first try. Polymaker first try. Okay, let me pause that. So this will save you 15% off your very first order. So this is to allow you to try some of the filament that you want to try, whether it's our silk PLA, whether it's our Polytera, whether it's one of the 30 different materials that is behind me, engineering materials. So you can try with that coupon code. We have many different programs. Yeah, I would like to tell you this. And if you can spread the word, that would be awesome. We do have a special 5% off for Etsy store owners. So if you are an entrepreneur, a creator that is selling on Etsy, you can have a coupon for a 5% off. And for all your orders, you just have to contact us with your Etsy store link, and then we will confirm that the store is yours, and then your account on our website will have a 5% off. The same for we have an education. So if you know the purchasing team of any schools, or if you know any schools that needs filaments, if they come to us with the tax exemption certification, then they will also have an account with 5% off. We also have a 5% off for all the orders above $500, and a 10% off for all the orders above $1,000. And then there is a lot of influencer out there with some very interesting coupon code as well that we can check. And I'm currently creating some other program in order to help many different communities. For example, we are soon going to release a coupon code for the robotic communities, so that anyone from particular robotic association will also be able to supply their spools from Polymaker. So yeah, just a small advertisement part during that stream. Thank you, Jackie, for asking. So you can find the coupon code in the chat. I just sent it out. us.polymaker.com. Unfortunately, we don't have websites set up in Canada and Europe yet. Canada is coming soon, and Europe is still under construction. Non-fan, there are two different ideas. 3D Make. Okay, any other ideas on how to decrease printing time? Yeah, I like when I get the chance. One last did. Tri-angle support work great. Builder's mark. Yes, definitely. Model orientation. Yes, Santiago. So that was the third one of what I was thinking. So what I was thinking in my mind, which I usually use, is layer height. The second one was what? Oh, support management and model orientation. That is very, very important. Why? Because there is a huge difference in 3D printing between the Z speed and the XY speed. So I don't know what Santiago meant by model orientation. It could be support management. You can manage your support, like the lowest amount of support by tweaking your model orientation so that you don't need so much support. But what I usually use model orientation for is to make sure it does not use the Z axis too much. So let's say I want to print that guy. Okay, so if I want to print that guy, theoretically I would. So this is the best orientation, right? But just it's not the right model, but just for you to understand. So if I print this model, I will first put this model like this, and then I will check the printing time. It's a very bad idea for this model because most likely I will create a lot of support, which is already a bad idea because maybe the printing time will be faster here because here there will be too much printing support. But even with the support, maybe this will be faster than this. I don't know. I need to check. But I won't do that because of the support will usually give a rougher surface than just printing outside. But you get the idea, right? Try to always orientate your model so that it takes the least Z axis length, right? So this model is obviously this is the best printing orientation. It was designed like this. But if you have any model that are more organic, or I don't know if I have any example here, but yeah, for example, this one, well, don't, like, okay, let's say you have to print this. So this was not printed in one piece. It was printed in 1, 2, 3, 4 pieces. But let's say you have to print it in one piece. What is the orientation you guys would have chosen? Would it be this? Would it be this? Would it be this? So for me, what I would use, let me think about it. I think here's my thinking process. My first thought was to print like this. Why? Because I will first make sure there is no support. So this is where there is support. The problem is now I'm realizing, okay, if I print like this, it means the layer will be in this way. It means if I want to play around, then I might either I need to use materials with a very good layer height, a very good layer bonding, or I would not print like this. I don't think I would print this guy like this. Then I will think about how to make this part stronger. And definitely this part would be the strongest one. Now I'm going to think, is this, because this is going to create a lot of support, right? Now I have to compromise between the support that I'm going to have here or the weakness that I'm going to have here. Then I'm going to think about, maybe I could print like this, right? If I print like this, then I don't need support anywhere, right? So maybe, I'm not sure. Maybe we can think a little bit more, right? Because we do have some nice detail here. So if I put it like this, then I might mess up the details. But overall, I mean, it was not printing in one piece. That's why the designer put details everywhere. But if it would have printed in one piece and I would be able to use it, then I think I would have printed it like this. Then I can print everything without support. And then here I don't have the layer height that are like this, that I would affect the strength. Then I think I would print like this. Just on top of my head, I think I would do it like this. So that's a little bit how I would, how I'm thinking before printing something. Okay, so that was the last thing. Try to minimize the Z length. Minimize the Z length. Great. So we came up with 1, 2, 3, 4, 5, 6, 7 different ways of drastically decreasing your printing time, and then we explain in each of them how to not compromise on mechanical properties or quality. So I think we did a pretty good job. Let me quickly check if there is any other suggestion. I guess you will have to get a chance. I will put it on my side. Okay, so let me remove this. Remember, enter I'm awesome in the chat for the chance to win Polymaker spool. So don't forget that. We will draw that in 5 minutes at the end of the stream. I have more samples. I guess I will have to get a chance to put on my side. Okay, Jay is talking about Cura use lightning infill as well help. Lightning infill, I haven't heard about it. Is that the infill that will only focus on fulfilling the infill that is required, but in the fastest speed? Like they are going to use the fastest path? Is that the one? I didn't know it was called lightning infill. Maybe I need to check. Abdullah, do you still have my email address? One Raz, do you still have my email address? Are you talking to me or someone else? Probably make a first try. Can use my email about it. We can talk off chat. Okay, so it was for someone else. Okay, so we have a question here. Yeah, I think one of the best would be if you can add Polymaker at the beginning of your question so that I can scroll straight to the question that are for the stream. And then you guys can, I love that you guys are talking to each other and then helping each other. So then it will make me easier to find the question for me. Maybe I will write it also somewhere. Polymaker, you will let me know when you're in Canada, right? Oh, when you are in Canada. Yeah, definitely. I will let you know. Oh, I didn't know you were in Canada. I forgot. But yeah, we are about to set up the website. It will be the same, but we will be able to fulfill all the orders coming from Canada. Oh, we have someone from Australia. Yeah, Australia. I mean, we have an amazing partner there. Go and check 3dprintingsolution.au. This is our partner in Australia. First, why it's an awesome partner is their knowledge about 3D printing is amazing. So at least if you have them as a business partner, you won't have any issue about printing. You can just get to them and then ask them any question. Yeah, their printing knowledge is very impressive. Loyal Moss, hi everyone. Hey, Loyal, we were actually taking the example of the helmet you're printing to find out how to decrease printing time. Just a quick summary. We brainstormed together and then we found 7 ways of decreasing printing time, if that can help you. But I think you already used most of them. Increase printing speed, increase layer height, infield density, decrease infield density or smarter infield density, decrease unnecessary nozzle travel, support management, bigger nozzle, and minimizing the Z length. And for each of them, we talked together about how to implement it without compromising on mechanical property and quality. So I think, to be honest, it was an amazing stream in order to brainstorm around that printing speed or printing time. Sorry. Builder Mark, using Polyterra Fossil Gray PLA 0.6 nozzle, a decorative nozzle, 180 for RGB strip. Oh, you mean, oh yeah, those big nozzle. Yeah. For RGB strip wall light display can be controlled. Make it look like you're printing on the wall. Ooh, that sounds like an amazing project, Builder's Mark. I love those nozzles. I've seen a model where you have a filament spool or like filament extruded, and then you can print the nozzle, a big nozzle separate, and then you can plug it on this, and then it looks like it's printing the coil of filament, which is pretty good. My second idea was to use my second idea was to use triangle or grid infill to lower print time. Triangle or grid infill. Some infill take more time, for example, during. Yeah, definitely. So that's what we talked about. The infill, the third point, infill management. I think the infill density, the infill pattern, speed, extrusion width, all of this is very important. Great. Marcel off Axis. I'm awesome. I know you are, Marcel. MK Ultraviolence. I'm awesome. Yes, non-fan, you are awesome as well. Michael, you are awesome. That's so good. Santiago, Builder's Mark. Builder's Mark, you're awesome too. That's great. Okay, we have a question here. We do all of that. We have the helmet down to 40 hours. Yeah, that's amazing. We also talked about, was it inside? Did I forget that? Yeah, we talked about, oh yeah, infield density. Yeah, okay. So infield density, because we were talking about the side of your helmet might not need infill. So you can just have like 2 or 3 shell and just start the infill at the top. But I guess, yeah, I mean, I'm pretty sure you already implemented all of this. Great. So yeah, that's 1 hour of awesomeness and 3D printing nerdiness. I think we end up with a great list of tips and tricks. So I will keep that on the side, and then when we are going to do our Reddit, how you call that, Red or whatever, when we will go on Reddit and help all the people one by one. Again, I have the idea on the later stream, on future stream. We just take 1 hour. We go on Reddit, because now I can share my screen, which is amazing. Let me see if that's working though. Let me see if that's working. Let me share screen, because we will do that for the giveaway. So, and then I will do this. So now, yeah, is it working? I think it is, right? And then I should be able to easily, yeah. You see that? Oh, StreamYard is awesome. It's so easy. Okay, so like I said, we are going to draw the winner. So we have 16 entries. We have 90 viewers. I know Loyal is not going to type I'm awesome. He has too many spools. He told me, you know, I don't want spool anymore. I don't want. So maybe that's why. Yeah, be careful. Mike makes build, aka 3D printer noob. I'm awesome without the apostrophe. You can rewrite this. So I will wait a little bit more that you guys are entering the last one. I think there should be 1 or 2 that is not in the drawing yet. I give you a little bit more time, and then I'm going to draw. So again, what do you think about the idea of, I will share my screen like it is now, so you should be able to see me plus the screen here, and then we will go on Reddit. I will go on the 3D printing forum, which has 1.1 million people, and then there's a lot of questions about 3D printing. We'll just go question, and then we will just answer everything. And then we will be that big machine of creating knowledge, brainstorming together like we did today, and then we will grow that 3D printing knowledge. I am wrong. I'm reading that as LM is awesome. It could be. Maybe you don't know which key. Maybe it's capital I, or maybe it's lowercase l. You don't know. Okay, so we have a few more entry. We have 18 entries, and I guess the last one is Loyal Moses, which who is awesome enough to not type "I'm awesome," so that you have more chance to win a spool. So I'm going to draw the winner now. I click draw, and then look at that. How awesome is this? Who is going to win the Polymaker spool of your choice? Congratulations to Omi is the winner. So, Omi, you can contact me at, I will leave my email here, nicolas.togotu@polymaker.com. Or you can reach me on Twitter, on Instagram, anywhere you want. I just dropped my email here. Please send me your contact information, your email or the phone number so that the carrier can contact you if there is any issue, and the spool you want, whatever spool. If you want wonderful silk material. Oh, by the way, Loyal Moses, did you see that? Did you see that? Did you see what we were working on or what? Small tease. I know you like teasing. How about that? Yeah, so Omi, congratulations. Again, we have some silk, we have some PLA Pro, we have awesome Polyterra. We also have some flexible, we have some engineering material. So just reach out to me. Let me know what you need, material, diameter, and color. And then I will send that to you. So thank you very much for everyone for joining the stream. It was really awesome. I hope you really like the new way of handling the stream with we have I can share the screen, we can do a drawing at the end, we can share the question on the stream. So if you like this, then I will just go ahead and purchase the StreamYard subscription so that we can have even more features to have fun together. So thank you for joining once again our weekly live stream talking about 3D printing, and I will see you guys next week.